Everyday Richard takes a flight between Aston and Beijing. On any day, the probability that the flight arrives early is 0.15. The probability that it arrives on time is 0.55, and the probability that it arrives late is 0.3. We're doing question C. 60 days are chosen at random. So this is the number of trial n, which is 60, which is pretty big, large value. Use an approximation to find the probability that Richard's flight arrives early at least 12 times. Because the number of trial here is big, and the question asks us to do approximation, so that is a normal approximation. To do that, firstly, we need to check the condition for the normal approximation. There are two conditions. Firstly, the product NP, number of trial, multiplied with the probability of success, n is 60, and p, the probability of success, is 0.15. It is equal to 9, which is greater than or equal to 5. Secondly, n times q. Q is the probability of failure, which is 0.85, equal to 51, which is also greater than or at least equal to 5. And therefore, the two conditions for the approximation are met. Next, we need to calculate the mean. The mean value mu equal to np, which is 9 there. And secondly, the standard deviation sigma will be the square root of n times p times q, which is the square root of 60 times 0.15 and times 0.85, and it will be equal to the square root of 7.65. I do not do the rounding here because the rounding will make the calculation less accurate. The next step, we need to use the continuity correction. As the value 12 here is illustrated as a column with the lower limit as 11.5 and the upper limit as 12.5, and the mid value here is 12. And the question asks us to find the probability that the airplane will arrive early at least 12 times, greater than or equal to 12. So we need to involve the value 12 from the left to the right, and therefore when doing the continuity correction, we need to involve the value 12 in the middle. And so we take the lower boundary, the lower limit as 11.5, and therefore the next thing we calculate the z-score. Z equal to 11.5. We deduct 0.5 from the 12, getting 11.5. Okay, and then subtract the mean 9 and divide the standard deviation square root of 7.65, and we'll get the z-score 0.9039. 0.9039. And lastly, we will use the normal distribution with the new variable x following the normal distribution with the standardized value. The mean is 0 and the standard deviation is 1. The probability that x is greater than or equal to 12 will be equal to the probability following the normal distribution with the z value greater than or equal to 0.9039. Normal CDF. The lower value is 0.9039. The upper value is a very, very big value, 99999, etc. And standard deviation, of course, is 1. And then the final result is 0.183. And it will be very close to the result calculated by the binomial distribution. So for this calculator, I cannot calculate the probability of success from 12 to 60. So I need to do it indirectly, meaning the probability using the binomial distribution. Probability of x greater than or equal to 12, meaning from 12 to 60, will be equal to 1, which is the 100%, minus the probability of x smaller than or equal to 11. Okay, so I will calculate this one. Menu 7, binom CD, and then the variable x is 11, n is 60, number of trials, and p is 0.15. This probability is 0.819. Okay, and then doing the subtraction, 0.181, which is very close compared to the approximation of the normal distribution. Thank you very much, and I hope to see you again later.